All right, it's time to answer everyone's burning questions as they set up the stage very quickly. Let us put together to invite our Prof. Yong and our expert panel members to take their seats. The panel discussion will be moderated by the chair of PUB's Coastal Protection Expert Panel, Professor Yong. Professor Yong is currently Professor of Civil and Environmental Engineering and formerly Senior Vice President at the National University of Singapore. His expertise lies in the field of infrastructure development, including several coastal reclamation projects in Singapore and Southeast Asia. I will now hand over the time to Prof. Yong. Prof. Yong, please, as the expert members settle down. All right.
Right. Thank you very much. And for coming for this session. It's interesting to know that generally there's probably about 150 to 200 of you in person down here. I understand there's also another 300 that's attending virtual. So, and we're seeing a lot of questions streamlining. In fact, actually, I was preparing a lot of questions here, thinking that maybe nobody will be answered. This is not necessary anymore. And I think I'm glad that there are a lot of questions coming in, but they tend to be all similar kind of question. So I'll probably, without further ado, I'll go on. And for those who have other program and schedule, I will try to end this at 5:50. I don't need the reminder 10 because I set my reminder on my phone here to remind me. And when it rings, it means I'll stop. Okay, I have a 5-minute reminder here. So I'll go with the first question. I think some of it is actually addressed particularly to people, and some of it is general. I just ask to start our colleague here to answer. Yeah, Dr. Jane, thank you for reminding us of the audacious effort to subdue nature. Singapore is a small island city-state. How would you actually embrace NBS since we have very limited land? How can we plan with nature rather than against nature? Jane.
Thank you. That's a great question. So Singapore has limited adjustment space, but you also have some really unique, important ecosystems. We saw the mangroves on the North Coast yesterday, and we're quite impressed, especially with the amount of wildlife that we saw. So you need that adjustment space, but there's more than one way to get there, right? You can get it by extending out as well as allowing it to come in. We've seen that quite a bit in the Netherlands, where they have continued to push out to give them that adjustment space. So I think you just need to be creative in how you think of adjustment. It's not all coming inland. You can also push it out. And I would actually turn it over to Marcel to see if he has.
Yeah, this is a very issue that you'll need all your creativity here to make these things work. You'll probably find out new ways of building with nature than all the examples that Jane has shown. And that's also because we're developing more and more knowledge. And if we apply that knowledge, we're able to find more and more solutions. If you go back in time, 2000 years ago, Emperor Marcus Aurelius, he was in love with Cleopatra, Queen of Egypt, and she had very feet that could not walk on sharp stones, right? So he wanted her to come over from Egypt and come over to him on an island called Sedir in Turkey or in Greece. I won't say what I think about that, but anyway, that island really exists. And he got sediments all the way from Egypt to build the mother of all nourishments ever. And that was carbonated sands he placed as a nourishment on that island. So what I'm mentioning, why do I mention this? First, because it's funny and it's good to know, but you must realize that it's a real good thing that we're talking about nature-based solutions, and authorities love it, and journalists, they love it. But if you go back in time, people have always been able to learn from nature. For instance, in northern Germany, the monks did already reclamations more than 1,000 years ago. And that was based on their knowledge of the system. So I always like to say, there have always been nature-based solutions, but as time goes by, we get smarter and smarter and smarter, also because our technology develops and because we know more and more about those systems, and we need to know more and more about those systems.
Thank you, Steve. You may want to keep the mic because second question is addressed to you. Thanks for sharing on the Mekong wetlands. You mentioned that for healthy mangrove to thrive, about 200 to 300 meters of land is needed to be set aside. Is this width applicable only to Mekong or is a replication, is that applicable as a rule of thumb for other areas with wetlands?
Yeah, that's an interesting question. That's what I wondered myself. And so I started to look a little bit in literature, and it's my impression that because the physical circumstances that mangrove need are also particular type of say cross sections that you find, and because of that similarity, I would say that's transferable to other countries as well.
Thank you. Again, the same situation, that while 200, 300 meters in Mekong is applicable, but in Singapore, as you know, 200, 300 meters is actually a very luxury space that we can ill afford. This is again, that's where we all say that if we actually have a smaller space, and as what Marcel says, we have to be more creative and innovative to come up solutions that is suitable for places as land scarce as Singapore. But at the same time, small can be beautiful because we have the opportunity to try it as a pilot test. Small is easily do it. We can do it fast. And a lot of cases that what we are trying to do in Singapore is that we become a pilot scale, and we then have to try to see how do we scale up for the rest of the region. We have similar conditions like us, particularly as what the sea level rise picture has been shown, that the most vulnerable areas many are in the coastal cities of Southeast Asia. So there's a lot of things that we can do, and then as a thought leader to then share experience with the rest of the countries here. Thank you. By the way, is anybody wants to add? I should have asked before I go on. Okay. Then the third question, this is not to anybody, but I would like people who have not perhaps tried to make an answer to this. How effective are barrages in protecting low-lying areas over the long term?
Good question. I don't answer it.
You can if you want. Okay, Robert.
Well, I think barrages can be very effective at protecting coasts, but the problem is that the coasts change. And so, for example, sea level rise. So that's really one of the fundamental questions that, and it will also depend on things like the difference in height between extreme events. So the slope of the exceedance curve will also be a key factor. So, I mean, people can be things like the Mose barrage in Venice has been discussed a lot, and a barrage gives you great protection today, but then you have to think through how it will evolve in time, what's going to change, and then you can start to think through when you might start to find problems. If you look at the Thames Barrier in London, climate change was not discussed when the Thames Barrier was built, wasn't thought about, but they recognized, because we had long historical records, that sea levels were rising. And so they did factor in a 50 centimeter allowance for rise in sea level based on historical observations. And recognized that they recognized they'd have to close it more and more frequently, and in 2030 they would need to do something different. That was the expectation. Now, as we've gone through in time, we recognise we can probably extend the life of the barrier somewhat, and maybe we can push it to 2070. But then a new barrier will almost certainly be built in London. So that maybe kind of gives you some thoughts on it, if somebody else would like to comment.
Well, I can comment about this generally. I think one of the things which is really important is we're talking about big infrastructure. We're talking about big investment, and it's a fixed, as we said, a fixed structure. So in due course with sea level rise and other changes in the area, you'll have to make adaptations, or maybe, as we are planning to do in London in due course, to build one or maybe two new barriers over the years. But often you find that these big projects don't necessarily protect everybody from flooding. And they won't necessarily deal with flood risks over the whole of an area. They're justified for areas where there's going to be a big loss from flooding, big commercial areas, big residential areas. So you can certainly justify, for example, in Singapore, big investment in infrastructure for climate change adaptation, because we don't do that, the costs of that and the interruption to society will be huge. But there will be pockets, and everywhere where we build these big schemes, which are not protected by the big schemes. And here we have to find more localized solutions. And this is why looking at resilience measures, whether we're talking about critical infrastructure, or we're talking about business premises, or we're talking about residential premises, how do we build more resilience into the areas which don't necessarily justify the scale of investment which is given by the big infrastructure components. So a holistic approach to managing flood risk in the context of climate change needs to look at that value and the investment, the cost benefits, and making sure that the risk is driven down to an appropriate level for everyone, not just those who are going to benefit from the big infrastructure investments. Thank you. Anybody else? Yeah. Okay. All right. All right. Thank you. So I'll just move on to this question, which I'll probably take it on myself. Can we ask, how does land reclamation, underground tunnels and caverns affect subsidence? Are there any mitigating measures to minimize such subsidence? For subsidence to take place, there are only two factors is required. One, you need to have soft material. So usually soft compressible material. Unfortunately, I found in a lot of coastal cities, particularly on Delta and the mud flats. The second thing you require is actually external loading. Your external load can come from land reclamation, where you start to put fill on top of ground. You can also add in stress in the ground by doing groundwater lowering. When you do groundwater lowering, you're basically removing the water from the ground. You are increasing the bulk unit weight of your soil. And if you have soft ground below it, consolidation or set subsidence start to take place. As Robert Nicol has shown, and I'm going to let him to add in later on, he's shown you a graph that shows many cities around this region. And you can see that even Tokyo and Osaka, before they stopped pumping, there have been settlement in Osaka and Tokyo. In the 1960s and 70s, there's a regulation to stop pumping. Immediately, the subsidence actually start to slow down and stop eventually. The same you start to see in many cities. And I was just speaking to Professor Adrian Law from NTU. He's actually chairing a committee on the subsidence of ASEAN coastal cities. In Bangkok, he was telling me that Bangkok is now very serious about trying to cut down on the groundwater drawdown. And you can we'll start to see that Bangkok itself will also start to slow down in its actually subsidence. Jakarta is still going on straight, while we have been working a lot with the people in Jakarta on how to provide potable. It is still a situation that requires a lot of political intervention. Otherwise, they just continue. And right now, I'm not sure whether they've given up the idea by saying that they're going to just build a new capital city in Nusa Tenggara. But that, to me, doesn't solve the problem, because that's what we did see. People will still continue to live in Jakarta, and people will continue to survive, I think, and use their own survival to get over it. But the challenge it is to actually stop the drawdown, the groundwater, pumping of the groundwater immediately. You do it. But that requires government investment of public infrastructure like putting in potable water and so on. So this is something that is a feasible method, but I think sometimes it is ability to want to do it. The other part of the question is, does underground tunnels and cavern cause subsidence? Depends. If you actually do a construction well, and now this technology is such that you can construct your tunnels and cavern with very minimum amount of settlement in your subsidence. And once you install the linings and support ground, if they are maintained and perform well, there's no reason why it should actually subside. So I hope I answered the question because quite a few people asked on that. Robert, you want to add on this because you started the subsidence issue?
I think you've covered it very well. I have nothing to add. You've covered very comprehensive.
All right. So the next question, so I'm going to order which they just showed to me. It's based on issue Slido is about votes, all the most important questions, but I'm going to go on this, but some of that has less vote, I feel is also important. I'm going to use my chairman prerogative to skip some and go into the one I think is important. This is to David. David, how does the cost of regular operation and maintenance of retrofitting measures, example, gates with mechanical moving parts, change over its life cycle?
Okay, well, to be perfectly honest, I should say that I can't answer that question because a lot of these measures we haven't had in place over their life cycle. But I'll just share a few general thoughts on that because it's a great question. And I think it's not just a question that really applies to flood resilience measures on properties. It applies to all of our flood risk management infrastructure. You know, how do we make sure that we maintain it in a workable state, that measures are implemented properly? Well, first of all, there needs to be a plan. And it may seem remarkable to you, but in the early fitting of property flood resilience, we had no plans. No plans were drawn out for maintenance, even where we should store floodgates, you know, demountable floodgates. Well, if you're a property owner, where do you put it? You know, do you put it do you put it around the back of the house? You know, if you're keen on gardening, like we are in England, of course, do you keep it under the lawnmower, or could you find it when there's a flood? Would you even know there was going to be a flood? You know, you're going to sign up to flood warning. So, what the Code of Practice has done is it's brought all of those things up. So, first of all, we know now that we're going to get much better usability. And I think that's the first point, you know, because we practice how these are fitted, we enable the property owners and the business organizations to understand what they need to do to fit these, how to sign up to flood warnings and all of that. And a lot of work has gone into actually minimizing the maintenance requirements of the equipment itself. We do have certification processes for a lot of the products that are now available. We have what's called a kite mark. You may have something similar here, I think, in Singapore for products. And part of that is to specify what the maintenance requirements are. But I can say for a lot of the measures that are installed, which are fixed measures, there's very little maintenance required. The only real maintenance required are for sump pumps, for the pumping equipment, and that requires regular testing and a bit of maintenance. But in general, the costs and requirements of maintenance is not large, but we only have the experience of that over a relatively short period of time. We need longer time to get some of this information fed back to us, but it's all looking pretty positive at the moment.
David, to keep on, because there's a follow-up question on this to you as well. And I presumably this person owns properties in London or somewhere, because he's asking what types of properties will be able to obtain government grants for retrofitting resilience measures, and how much grants will they get?
Well, I think when you see London on the newsreels, they always show the really expensive properties, don't they? And there's plenty of those in London, but not so much all of those. But basically the way the scheme has worked, it's tended to work purely on a post-flood incident. So the government doesn't make grants available proactively. It makes them available in response to floods so that properties can be built back better. And this particularly works well when it works in concert with the insurance sector. So basically, what the insurance companies do is they provide the funding for building back as existing, and the government grant then pays the additional amount for building back better. And that's how it works. So that once properties have been flooded, then the idea is not to have that same experience the second time round, and also in the longer term to be able to have affordable insurance. Now, we have tried really hard to get this into more proactive mode. Like many governments, they're not keen to shell more money out. They have not been that receptive to it. We are starting to move forward a little bit now into the more proactive areas, but this tends to be done on an area-wide basis. It's done on the basis of value for money, and it's all managed by the Environment Agency. So this isn't an easy handout. So it's not something that I think people are going to be able to go down to the local government department and just get some money off the shelf to do some work. It doesn't work like that. It has to be a part of an overall strategy, and it does work. I should say that I just personally, I don't live in central London. I live outside of London. I have no vested interest in property flood resilience. Okay.
Don't go away, David.
Don't go away. Okay, fine. No. I'm surprisingly popular here, aren't I?
This question is probably somebody who wants to invest in UK properties. But okay. I think also in some way your answer will also give us some reflection on what should we also be doing in Singapore. For areas with high flood risk, a potential home buys made aware of the flood risk before buying?
Yes, I mean, this is, again, I think it's a really good question, that, because what we were trying to achieve with the Code of Practice was making sure that money was invested wisely. And that, quite honestly, that whether it's a business premises or it's an insurance company paying for it, or people like Mary paying for it out of their own savings, that they actually got a good deal. That they weren't ripped off, that they got good value for money. And part of that is absolutely making sure that you need to do this in the first place, because there is no point in fitting inappropriate flood resilience measures. If it really needs an area-wide scheme, that's what it needs. And what we wanted to avoid was an inappropriate use of property flood resilience. It's not a panacea. It's not a one-size-fits-all. It needs to be done properly in appropriate areas to appropriate properties. And that's, I think, is what we are now achieving. Now we have this Code of Practice in place.
Thank you. I think the next question, Tony, you're very quiet, so not going to let you off on this, but there's quite a number of people who ask the same question. Professor Dalrymple, would you be able to share what are the key factors to ensure accurate measurements for relative sea level rise?
To ensure accurate measurements. I think that the technology exists for accurate measurements already. I think tide gauges, for example, with GPS controls, such that we know that the land motion is being taken into account, as well as the sea level rise is being measured. So I think when I showed the slides of all the toys that people have around the world to make all of these measurements, I meant that to be impressive. That there are impressive tools out there. The Argo program is just impressive. The fact that these 4,000 buoys are going up and down and transmitting by satellite to get the data back to scripts. So I think the technology is reasonably good. I mean, we can always do better. We can do better measurements. And I'll share a story you may not know, but the gray satellites that I think are really cool, the 2 satellites that are chasing around the Earth to measure ice and groundwater and so forth. The first mission, the first GRACE mission, was so successful that the data was really good, and they really liked the data that was coming up, that they convinced people that there should be a follow-on mission, the GRACE follow-on mission. But they had to make the satellites exactly the same as the first set of satellites, such that they would get the same kind of answers. But technology had moved on, so chips were different, and so they really had to scrounge to find old parts to make an old satellite with new batteries and things like that so that they could have the follow-on mission. So people are trying very hard to get very accurate measurements and to get continuous measurements. So it's very important to have continuity.
Thank you, Tony. Robert, you want to add anything on this? Yeah.
Well, I think as well as looking at relative sea level rise, I think when you're thinking about the future, it's also useful to look at that global sea level rise as well, because local sea level will deviate substantially. Some of these regional trends means that sometimes you might not see things coming. So it's always wise, I think, also to keep appraised to what is coming out of the global measurements and sort of use the two together, because you're always going to focus on the relative. But if, for example, one of the debates around the Southern North Sea is we don't quite see as much sea level rise as global mean, and they wonder, well, why? And so there's sort of, and we're feeling that maybe in the end we will see that sea level rise, and maybe it's been held back by other processes. So I think it's always best to think about what's happening globally as well, if the relative sea level rise is smaller than you're seeing in the global trend.
Thank you very much, Robert. The next two questions is for Jane. Again, it's related to nature-based. Is it possible to share any case history on NMBF that were deployed that did not work in the end? Any ideas on the type of NMBF that could be implemented given the limited land? I think that we already answered that part. So I'll just come back to this. Anyone that's deployed but did not work in the end?
People don't like to share things that don't work. So I can't think of a specific example, but I know there are examples of failures where the vegetation hasn't developed well, or you've had a breach in systems. So I think it's super important that we start documenting failures as well as successes. So I think that's an important part. What was the second part?
Any ideas on the type of NMBF that could be implemented given the limited land in Singapore?
So a hot topic is hybrid solutions. Using a combination of different NMBF or maybe NMBF with a hard structure. And I think you've all seen examples of that where you maybe have mangroves, but you still have a seawall behind them. There's lots of examples where people may build a dune, but they don't have enough space for the full beach, so they bury a seawall within the dune. Maybe a case where you put a submerged breakwater in front of maybe a mangrove forest to reduce the wave energy coming in. So there's lots of excitement about using these hybrid solutions. The biggest problem with that is there's very limited data on it. So there have been experiments starting now where people are looking at the combination of different features. At the recent International Coastal Engineering Conference, one of the researchers from Spain looked at having vegetation in front of a seawall with the idea that you could reduce the height of the seawall. She ran the experiments and found out that vegetation had very little effect on the run-up and overtopping, probably because the vegetation only dissipated the short period energy and not the long period energy, which contributes more to the overtopping. So there's so much we don't know about these hybrid systems. And I'm hoping your new consortium will be focusing on some of those issues. I think that is an opportunity to reduce the space required, but we still have a lot of research to do on that area.
Anyone add in on this? Okay, then Jane, follow up again, since you have the mic. What kinds of modeling tools are currently available, if any, for engineering planning, such as where to place mangrove oysters along the coastline?
So a lot of our modeling tools, Delft tools, some of the Corps of Engineers tools do have the capability to put vegetation in them, to put features where you can put in the roughness, so reefs and such as that. So there are a lot of tools available. The Corps of Engineers has been developing a GUI that allows you to quickly place in different types of natural infrastructure for the testing. So there's a lot of numerical modeling tools out there right now that exist. And there's a lot of literature on that as well.
All right, thank you again. Anyone want to add on this? All right. Then move on to the next question. Is also related to subsidence, but I'll take a try on this one. And, land subsidence for the two Taiwanese cities, Taipei and Yunli, are different. And given the steep subsidence for Yunli, which is in Taiwan, do you foresee any implication for this city, meaning in Singapore? I don't know whether it's you referring to Yunlin or you're referring to Singapore. But I take it that first I explain Yunlin, then I'll see whether is there an implication for Singapore. I think in the case of Taipei and Yunlin, they again the same situation. In Yunlin is basically an agricultural area, so they do a lot of drawdown because you need the water for agriculture. And that's essentially the same thing I mentioned. You need two ingredients. That you need to have soft material. You need to have load that's placed on the soft material. In this case, extraction of groundwater increases the weight of the overburden above it, and that causes the subsidence. Will it happen to Singapore? And I don't. This is a little bit of history lesson for those who are born much later. In this before the pre-60s, some of you, if you are familiar with our shop houses in the central courtyard, there's always a well in all those houses before we move on to HDB, high-rise and all this. Many of us were staying around Chinatown area, Beach Road area. Beach Road was subsiding because of the drawdown of groundwater, because there's a lot of marine clay over there. In the 60s, when the government started to provide potable water and ban this drawing of water, subsidence stopped. But when we do reclamation, that's where you also continue to have a settlement taking place. But a lot of cases, settlement, they don't take place immediately for a long time. And in areas where we made the land early, we do ground treatment to actually accelerate or what we call pre-consolidate these subsidence so that in any person who come into use will know we're not there. But in many cases, a lot of land that's been reclaimed are actually settling. And so these are something that has been always taken into design, whether in terms of foundation or in terms of drainage and so on, including even for land transport that are actually placed in area that are settling. These are all consideration in the design of the tunnel regarding movement and differential movement. So I think as long as we do not do any groundwater lowering in this Singapore city, I don't think we will have that problem. But because we are continuing to reclaim land over soft ground, these subsidence will have to be calibrated, controlled, and designed for. But certainly it's not the same as what we have seen in many of these subsiding cities because the drawdown is tremendous. It's over a big area because of the population requirement for water and so on. And this actually caused that subsidence. Robert, again, do you want to edit? Yeah.
Hello. Yeah, okay. I think the large area subsidence really happens on deltaic deposits. So where you're talking about Tokyo and Osaka, those areas that were subsiding, you're talking about two deltas that existed within the city. In Tokyo, I think about 1 million people live on that around the port area. Tokyo is a city of 30 million people, so you can see we're talking really about a small part of the city. But these deltaic deposits are geologically young, not fully consolidated, and so when you withdraw groundwater, you cause very significant consolidation and permanent loss of volume, so a loss of elevation. And I think also then looking at places like Singapore, the INSAR satellites, which are now providing very detailed information about vertical change in land elevation, provide a means where one can actually start to monitor this, and within cities maybe find the local areas where you might see substance. I guess in most cities you're going to find areas of land reclamation, and particularly areas that were reclaimed maybe a long time ago when we didn't have very good standards, we didn't even understand these processes, and these are areas that might be prone to these types of processes. But I think in many, if you're not in the delta, these are probably going to be localized or much smaller than the rates I was showing in many of the Asian cities that I illustrated. Thank you.
Thank you, Robert. Anyone to add on this one? Okay, if not, I'll move on to the next question, which related to sea level rise. In every IPCC report, sea level rise rate changes. If someone wants to design for the next 100 years or more, what would be the best way to select more realistic SLR rate, other than reading up the IPCC report? And we are looking for AR7 that's going to come shortly. I'll just leave it to the CEDA panel. Anything to add on it?
Well, I mean, I think the way I would approach it is in terms of really, you've got a range of numbers there, and you need to look at the time scale of your decision, and also consider your risk tolerance. So there's a few things to sort of think through. But with long-term infrastructure, when we're thinking big sums of money, I think probably one would go. If it's a nuclear power station, you might be very precautionary and go for the very high end that Tony illustrated. But another practical way is to maybe go for something around the median or a little bit higher than the median, like the sort of the 1 meter type of value. It could be more. And then you also, as a thought experiment, ask what would happen if the number was at the high end? Does that invalidate my design for 1 meter? Could I, in a pathways approach, could I sort of bring forward maybe the next investment I might think, and the problem is not a too big a problem? So I would sort of advocate that sort of pathways approach, whereby you think about, you think through the consequences for a high end, and can you deal with it? And so you're thinking about multiple steps. That kind of, I think, gives a bit of flexibility. Equally, you could ask, can you take a short-term decision to buy time, such that you've got the AR7, maybe AR8 and AR9 published, so maybe the science becomes more certain.
So I also think it's important that you get your own data. So there are tide gauges around Singapore. They're not all GPS corrected and so forth. So I think building your local expertise and your local database, CCRS does a great job at looking at future sea level rise. And I think maintaining that capability, updating as time goes by, updating based on the local data that you have, your own tide gauge data, plus you got access to all the other instruments in the world that are associated with sea level rise. So I think having a local capability to see if Singapore is following the global trends, and then knowing where the possible tipping points might be, where maybe now we don't need a barrage, but maybe we need one later. So by having your own data, then you can make those kinds of decisions more wisely.
Can't get the staff, it's a problem. I think look at our experience with the Thames barrier, we had exactly this challenge. We knew the life of the barrier eventually was going to come to an end, and we need to replace it. And when we got into that study, I mean, the danger with it is to get too hung up on timescale. So you start to think, well, what's going to happen in to sea level rise over time? At what point in the future is it going to reach this level? But actually, that's not really the issue. The issue is, at what level do you need to start doing interventions? It's building on Tony's point about having good local data and understanding the consequences of sea level rise. So the effort with the Thames barrier has gone in to understand the consequences of sea level rise, and at what point, Tony used the term tipping point very wisely, I think, here, because at what point does this become a problem? At what point are you no longer defending parts of your area, and you need to improve that? So that defense. So the forward plan is based on identifying those tipping points. So we have the tipping points now. So when it gets to a certain sea level, we then implement the next stage of the development. The other point I'd like to make is also to look at incremental improvements. Is it possible that you don't have to do the improvement all in one go? Could you do it in parts? So what the Environment Agency has started to do in the UK on some of the coastal defences, it's started to look at the potential of long-term sea level rise. So when it builds a new flood defence, it'll put in the foundation for the long-term defence, but then it'll build up to the more shorter-term requirements, knowing that in the future, it can then build on top of that as and when any additional protection is needed.
All right. You want to say something? Yeah.
Yeah,
Mr. Hassan.
I'd like to add to this discussion that if you look back over time, and Tony brought this point in very clearly, is that what matters is the rate of sea level rise, because that can totally turn our whole physical and natural systems around. It's at sea level rise rates around 1.5 to 3 meters per 100 year, that the world would look totally different physically. There would be no deltas. There will be no barrier islands or dune ridges. And so that will cause a fundamental change in our environment. And that's only thinking about our physical environment, but think also historically, when started people moving around the world, that was when there were shifts in temperature patterns that were so quick that they had to move with the climate. And so I think once we're reaching those rates, then we have really a problem.
Okay, Master, you may want to hold on this one. Can the panel advise how they see the role of spatial planning in delivering coastal protection, such as managing, adapting land use, engaging communities, etc.? Do you want to take on first? Or,
Well,
okay.
if anyone else says it.
Okay, I'll probably start it off and then I'll see whether colleagues are doing it. I think particularly in Singapore, as you know, land use is very, very important. But the fact that we are going to have a coastal master plan give us an opportunity to actually integrate land use from the use of space from the land and the sea. I mean, coming from somebody who is not in the government, what I'm very pleased to see that this fact that we are looking at coastal protection is now giving us an opportunity to redefine not only the coastline, but an opportunity to see how we can integrate the space of the land and the sea into one bigger master plan. I'm not sure whether I answer that. And the second part is about how do we engage the community. Now, I'm speaking on behalf of the PUB, but Hazel can certainly answer that part if she wants to add on to it. They're already having several engagement sessions in different forms. Some is just through into the media, like podcasts, YouTubes, and so on. So you go into the PUB website, there's other engagement. Some of it they're engaging through, particularly when they're doing the APA1 study, a conversation with the communities around. I'm quite sure more of these will take place as they actually try to look into how communities can play a role in defining and shaping some of these coastal protection measures. And certainly as you start to look into the nature-based areas, into our mangrove wetlands, nature groups will be consulted and will be working together with the PUB and so on. Hazel, have I spoken something or do you need to add in some more?
Perhaps just to add on another dimension to that, other than engaging communities, I think we are also very interested in working with the industry professionals, because as we roll out the protection works, we will definitely need more designers, we will need architects on board, we will need implementers, we will need suppliers to roll out all this program and to construct the actual measures. So as you have heard from the panel, we will need innovative and more novel solutions. May not be something that we already know today, but as we develop them along the way, we will need people who can actually deliver them on the actual sites that we will need them implemented. Yeah, thank you.
Thank you, Hazel. Master, you anything to add? No? Yes? No, okay. Then I move on to Professor David again, Bamford. Would you say that people need to experience floods to really start taking action to prepare for them? What are the possible reasons to push business owners and homeowners to take action in London?
Well, I wouldn't advocate artificially creating a flood so that people could experience it. Okay, so just to be clear on that. on a serious point, what is really good, I think, for engineers in particular, but anybody, any professional involved in managing flood risk, is to actually get to meet people who have been flooded, because it is a very moving experience. So the sort of things that people say to me is, you know, I can't sleep at night when it's raining. I have to get up and out of bed and go downstairs or go in through the building and see whether there's any flooding, see if we're being flooded. So they get no peace. And they also say, I can't go away on holiday in case it rains while we're away. And, you know, one of the things about flood barriers is if you've got a demountable flood barrier, who is going to install it when you're on holiday? And you know, you don't want to leave it installed when you're on holiday, because it basically says, look, folks, we're on holiday, you know, come and rob our house. So, and you know, it's okay, but it's all of these things that are really, really practical, the human dimension. And when a flood scheme is delivered, whether it's a major flood protection scheme or it's an individual property flood resilience, the benefit and the change to people's lives is huge. And the value that we all do as professionals in helping to deliver that is enormous. So I just really, I think that is, you know, the thoughts I wanted to share with you. And now I'm not sure that I've actually answered the question, have I? But anyway, come on, somebody else wants to have a say.
So I think the answer is no. You don't have to experience a flood to get concerned about flooding. And to illustrate that, sea level rise is a flood. It's just taking a long time to get here. And we don't want to wait till sea level rise occurs before we do anything about it.
Thank you. This could be. So my alarm just rang to say there's 5 minutes to close the session. So I'm going to just take on the last session and move on to the closing part of it. I think this is an interesting question. Professor Nichols, is it possible that the sea level rise is higher in the East, Southeast Asia is due to the uneven Earth gravity? And what possible human-induced subsidence is observed disparingly from different parts of the world in terms of the identified location mentioned in your slides? Maybe you take the first one first. Is that possible that the sea level rise is higher in the East, Southeast Asia due to the uneven Earth gravity?
Well, I think the answer is, I mean, the honest answer is I don't know. I was discussing with somebody at the break about the effect of water withdrawals on the Earth's gravitational field and how that might actually have localized or regional effects on sea level rise if there was groundwater mining, and I suppose which is implicit with the substance that we're seeing, and also some of the issues we're seeing in deltas that Marcel was showing in the Mekong. So I think that's probably a hypothesis that would be interesting to explore. I think, but in terms of the analysis that we were showing, we weren't really including that, but that would be a fairly small effect compared to what we were showing. So I don't think it's really going to influence the results that I was showing, but it could be an additional effect, particularly in places like in some of the deltas. It wouldn't be across the whole region, but it might have an effect at the scale of deltas if the water withdrawal is sufficient. What was the second question, please? The second part?
I thought that the second question is really in some ways discuss about the subsidence that you observe in these parts. Does it differ from other places in the world?
Well, I think that the substance in this region, if you like, and I say this region, it's a huge area I'm talking about. So I'm talking about from Pakistan all the way down to Singapore, Indonesia, and up to China and Japan. So it's a very, very large part of the earth. But the reason that this area subsides so much is there are so many deltas. So basically, I think that the reason that there are so many deltas is the monsoon climate. So I think there's very large seasonal runoff. And the Himalayas, you've got huge relief. So you've got the biggest mountains in the world providing huge amounts of sediment. So I think those are the two factors that have given you the deltas. They're great places to live. And then you're modifying that and in the way you're living it by withdrawing groundwater, which is causing the substance. So that's really what's giving the difference in this part of the world.
Thank you, Robert. Sorry, Tony. Yeah.
But if it's any consolation, there are plenty of places in the United States where subsidence is a very big issue, with meters of subsidence, either by groundwater withdrawal for agriculture or oil pumping and so forth. So Houston, Texas being an example, Los Angeles basin, an immense amount of subsidence. So it does occur everywhere.
So, okay, before I close, I just have asked the panel to just as a 1 minute takeaway point for people attending this symposium, for either them to as a suggestion, a tip, or just to think about. Maybe I'll start with David at the end. Just 1 minute.
Well, I think it is the human dimension, and I think one of the challenges we face with climate change, both in terms of public perception and also in terms with the response of the different responsible bodies who look after us, is it's in some ways it's a gradual phenomenon that occurs over a long period of time. So there never seems to be an immediate driver for investment or change in lifestyle or anything else that we do. And I think, I'm going to fill the gap for not answering that previous question now, but I mean, I think getting over to stakeholders and the public, that this is really happening. It has to be dealt with. From a government point of view, and I think it's really tricky for governments, we have to establish a long-term consistent investment program and a forward plan to deal with whatever the measures are that come in. So I think it's how we engage with people, how we get it into people's minds, how we get it onto agendas, how we get the commitment to long-term action is a real challenge, I think, for those of us who have a real and genuine concern about climate change and flood risk.
Thank you, Robert.
Well, I think I would say it's relative sea level rise that causes the impacts that we see, and the need to adapt. And therefore, it's really important to understand that relative sea level rise and that really, I think, means a lot more effort to really understand some of these vertical land motion issues and how we can address them. And in the importance maybe of organizations like the World Bank, the Asian Development Bank, intergovernmental organizations. I was having discussions in the tea break about activities that are going on. This is all great, but to really make sure that those activities take place and this is acted upon.
Thank you, Marcel.
I'd like to extend Robert's comments. We are often being asked by journalists, what about sea level rise? And so they come to you with the idea, this is a global issue, and are we going to drown, et cetera, et cetera. And then I always end up by explaining to them what we talked about, that it's relative sea level rise. That's very important. And it's an order of magnitude more important than eustatic sea level rise. And because we have caused an order of magnitude larger than eustatic sea level rise, and we still could cope with it, we are still all right. Of course, it can go wrong when we go to increasing rates of sea level rise, which exceed 2 meters per century. But as long as that is not the case, we have plenty of other problems due to climate change that we need to deal with. And I just mentioned that the drought at this moment in Europe, it's amazingly dry, and we need fresh water in our river systems and in our reservoirs. If we look at agriculture production, which is depending on it, you see with the war in Ukraine, there's only one country that doesn't produce and we're in trouble. So I always say to the journalists, I'd love to talk about sea level rise, but we have bigger issues due to climate change and due to what we do as humans to our environment.
My closing remark is that I am very impressed, and you should be proud that your country is doing so much about sea level rise. I think if we compare it to what we're doing in the US, it's orders of magnitude ahead. And I think it's a very ambitious and very well thought out goal, and good luck with everything.
So my colleagues all gave very brilliant summary comments. I'm going to take a little bit different approach. I want you to all look around the room for a minute. When I look around this room, what I see is a lot of diversity, cultural diversity, gender diversity, and probably most important, discipline diversity. Landscape architects, biologists, ecologists, engineers, all kinds of scientists, climate scientists. To solve those hard problems that you have, you all are going to have to work together. And I see that you're here and you care, your organizations are working together, and it gives me, great hope that we're going to solve some of these hard problems of how we deal with the coastal squeeze and using NMBF and hybrid solutions and dealing with sea level rise. So I hope that you truly appreciate what you've got here. It's very exciting, and you're going to come up with those innovative solutions that Hazel said that are needed. Thank
Jane.
you.
Good way. Well articulated. In fact, there are still many more questions. I must apologize to those who've taken the time, but I suggest that, just at the Google, you have the address, you can write directly to them. If you still feel that you have some questions, I'm quite sure they're all very accommodating to try to answer some, but don't use them as free consultants to get all your answers. With that, I'd just like to conclude so that the sea level rise and climate change knows no boundaries. And so this is a reason why for Singapore being a nation to try to get to know more about it, we have to fast track a lot of things. And by going to learn from other practices, international, overseas, bringing in all the expertise here to Singapore, talk to people, is one way of trying to accelerate our learning process. And the ability to distill this learning into and contextualize into our landscapes area, so just is very important. And I work with the panel, and I'm very happy that they're actually able to look from our constraint both in size and resources, and able to try to contextualize what will work. In fact, sometimes they caution us, this thing won't work, because we cannot just look at what has been done in other countries and try to just duplicate it in Singapore. We have a size constraint, we have a resource constraint, but I think it's something that we can take the opportunity to actually use Singapore as a living lab, as a place to test out new innovative ideas and see how we can share it and scale it up to the rest of the Southeast Asia. With that, I'd like to take the opportunity to thank the PUB and the management for inviting us on this one, and also for all the attendees, and most important for the organizers put together, and of course the MC, Jeanette. With that, thank you very much and have a good day.